Our three trigonometric functions, sine, cosine and tangent, are going to have two angles which will give us the same value. Now I'll show you what I mean by that. If we were to take the point on the circle and rotate it around the circle, and we were to look at the sine function, you'll see here that in this instance here we have the white line here which exists at 46 degrees. And we have the blue line here which exists at 134 degrees. Now the height of the white line and the blue line is the same. So what we're really saying is the sine of the 46 degrees should be equal to the sine of 134 degrees, simply from the symmetry of our sine function. And if we were to move this to a different angle, so you could see here that we'll have the sine of 40 degrees should give us the same value of the sine of 140 degrees. So in this sine function, there's going to be two angles which will give us the same value for the sine function. Now we can generate identities. These are little mathematical equations which relate the value of our 40 and our 140, and we will look at that later on in the course. But we're just going to get a good intuitive understanding here. So in this instance, you can see here we've got 40 degrees here. So if the line running down the centre here is going to give us a mirror symmetry between this side here and this side here, it means if this is 40 degrees, then this length here must be 40 degrees as well. So we can get this other angle if we take the 180 and we subtract off the 40 degrees. So it means that the sine of 40 degrees is the same as the sine of 180 minus 40 degrees. Now let's put these into the calculator and we'll see whether that is the case. So if you make sure that you're in degrees, and we're interested in the sine of 40 degrees, and that's going to give us a value of 0.6427. Now that should be the same as the sine of 140 degrees, which is 0.6427. So it does work. So we have two ways that we can remember this. We could remember the trigonometric identity, which is sine of theta is equal to sine of 180 minus theta. Now we will be writing these trigonometric identities down later on in the course, but for the moment what we want to be able to do is a different way. Rather than memorising trig identities, we want to be able to generate the correct answer for ourselves, and we do that by ensuring that we know how to draw out the sine function and also the cosine function and also the tangent function. So if we're learning trigonometry, at the very least we should be able to put these three functions, the sine, the cosine and the tangent, to memory. Now if we have these in our memory, then we can work out geometrically the angles which give us the same value for our sine function, because you can simply see them. If we work our way along the curve here, you can see that the white line and the blue line are going to give us the same value for the value of our sine. And you can see that the blue line is going to be generated by 180 minus the angle here, which is 62. So that's going to be the angle of sine of 62 is going to be the same as the angle of 180 minus the 62. So we work it out geometrically by ensuring that we know what the sine function looks like. Now we can do the same in the third and fourth quadrants. So we're going to rotate the point in the circle from 180 degrees round to 360 degrees. And you can see here, if we pick some arbitrary angle, we have the white line here which represents an angle of 220 degrees. And we have the blue line here, which represents an angle of 320 degrees. And you can see again the height of this white line is the same as the height of the blue line. So it means that the sine of 220 degrees is going to be the same as the sine of 320 degrees. And you can see this again purely from the symmetry. So how do we get the second angle 320 from the 220? Now, as I mentioned, we're not going to be looking at the actual trigonometric identities in this video. We'll leave that for a later section. We want to get intuition here, and we want to generate the answers graphically. So what we could do is we could look at this length here, which is an angle of 220 degrees. And we know that this little length here is going to be the same as this length here, simply because of the symmetry of the curve. So then all you need to do is work out what this angle here is. Well, this angle here is just going to be the 220 minus the 180. So this angle here is going to be an angle of 40 degrees. So if this is an angle of 40 degrees, then the angle to this point here must be 360 minus this 40. So 360 minus the 40 is 320 degrees. So we can say that the sine of 220 will give us the same value as the sine of 320. And again, you could pick another one. So here's another one here. We're going to have 230 degrees. So we take the 230 and we take off this distance here, which is 180. We're going to be left with an angle of 50 degrees. So this is a 50 degree angle from here to here. So it must be 50 degrees from here to here. So if we take the 360 minus the 50, we're going to get an angle of 310. So again, you've worked this out purely from the symmetry of the sine function. Now, there's another thing to note here as well, is that this curve here is exactly the same as this curve here. The only difference is that the negative values here would be the same as the positive values up here. So let's look at that in the next simulation. So let's take this up to some arbitrary angle, say for example 210 degrees. So we can see here from this point to this point represents 210 degrees. And we know from what we've seen previously that the sine of 210 degrees is going to be the same as the sine of the 330 degrees, which is this blue line here. But because of the symmetry of this, we can see that this shape here is exactly the same as this shape here. The only difference is that the negative values here will become the positive values here. And I've put in the two positive values. And we can see the angles for the two positive values here. One is 30 degrees and the other is 150 degrees. So the height of these lines here are going to be the same as the height of the lines here. But one is going to be positive and one is going to be negative. So we can see here that if we were to look at the sine of 210 degrees and the sine of 330 degrees, we would get the same number if we were to look at the sine of 30 degrees and the sine of 50 degrees. The only difference is that one would be positive and one would be negative. So let's put these four into our calculator just to confirm that that is the case. So make sure your calculator is in degrees. We're going to put in the sine of 210 and it gives a value of minus 0.5. So we'll cancel that and we'll put in the sine of 330 and it should give us exactly the same value, which it does, minus 0.5. But now we'll put in the sine of 30 degrees. And this should give us the negative of the answer for the previous two. So this gives us the value of 0.5. And if we put in the sine of 150 degrees, it gives us the value again of 0.5. We can generate trigonometric identities from what we have learned here. Now, if we look, for example, at this angle here, which is an angle of theta, then this angle here, from this point to here, is going to be an angle of minus theta. So we can see that the sine of minus theta gives us this point here, and it's going to be the negative of the sine of theta. So we generate the trig identity, the sine of minus theta is equal to minus the sine of theta. Now don't worry too much about these trigonometric identities, I'm only just mentioning them here, we'll have a whole section on them. Now we really don't want to be memorising lots of trigonometric identities. What you want to be able to do is draw out the trigonometric functions, understand the symmetry of the functions, and from that symmetry the identities will become obvious. Now in this video we're only going to cover the sine function, but the same symmetries exist for the cosine and the tangent. But we're going to leave those symmetries as an exercise. So thank you for listening. I'll get you on the next video. Goodbye.